just took a long time to start recording because I'm doing something else in the background, and I'll show you guys. You will have to do it too, but it will take a long time, so I'm not sure whether we should do it in the class because I'm not sure how long it's going to take to finish it. 3 hours should be okay, but it's going to take a long time. All right, so we'll go back and take a look at where we should be at this point. Live distribution with an external hard drive. These two should be done today. Okay, we spent 2 weeks to work on it. That's because I did not anticipate the problem with larger capacity hard drives, using GPT or GUID partition table. Okay.
Which two did you say that? Which two? You said these two?
Oh, those two would be.
Oh, the lab and the live.
The lab is just the description. Basically, I expanded the description to include everything that I have recently learned. Okay.
Okay.
And then this is the quote-unquote homework that I need to check off. Once I go to your workstation, they go like, oh, this is done, and so on. Okay. This is really just a roadmap of what we'll be talking about in this class. We talked about that last time, so I'm not going to talk about it again today. And you won't see the. Sorry.
That's the one that I was looking at that I said to do. I'm like,
yes,
oh my gosh.
They are all to-dos.
Is that all our homework?
Yes. Well, the to-do is not for this class. The to-do is basically how do we counter these things? How do we fix this problem? So these things can deal with the issue that was described.
Oh, I see.
So that's what a to-do means. It's
okay.
not a. It is kind of a to-do for us as well because we will cover these topics in this class. But the to-do, the meaning of this word here is actually to say, okay, to deal with surfaces and ports that should not be external or should not be exposed. These are the things that we should do.
Oh, I see.
So that's what
I was
it
so
means.
behind on my homework. I'm like,
oh no. But thank you for your email. I mean, it's definitely okay. It's not a problem to let me know. Okay, I got a concern here, and I like a class where people are, concerned about are we falling behind as a class? Are we going to have enough time to cover all the topics? That's otherwise we don't need the class. Okay, so you won't see the grayed out stuff. Don't worry because that's old stuff. I really do not like the organization of the syllabus itself. Okay, and we are moving on to assessing and adjusting network services today. So there are multiple topics here. They're all in the quiz form, and I will change all of the quizzes so you can reattempt as many times as you feel like it. Okay, so that's going to be fixed. I wouldn't worry too much about that. What is going to be practical and useful today would be these things. I did not have enough time to turn everything into quizzes. So there are still these HTML documents that simply has all the writing in text. Okay, so they're not interactive. You don't have questions to answer after each page, but nonetheless, this is actually useful information. And as a hybrid class, you really should spend some time to read ahead of me. And if you have any questions about these terms, I can answer those questions during class. But concept stuff, you have to spend some time offline or off class to kind of read about it. If you have any specific questions, bring it to class and we'll talk about it. But in class, I would much rather spend the time to illustrate, how to get things done. Okay, so not the concept stuff, but more specifically how to get things done. Unless we're doing something that is very time-consuming, and since I'll be waiting anyway, I'll go ahead and talk about the concepts as well. Okay, so this slide is the introduction to how do you assess a computer and find out from the networking perspective, do we have any problem? Okay, this is the actual practical, hands-on stuff. The first part, the first paragraph, talks about the two methods to do it. One way to do it is to do it from the inside. Okay, the first method is check from the inside the machine, and there's one particular command that is extremely useful for that purpose. But it doesn't really do anything, well, it's useful on its own, okay? But that assumes you have administrative access on the machine that you're assessing, okay? Which may or may not be the case, okay? The second method is to look from the outside. So the second method is to scan the machine that is being accessed from the outside. So you don't need administrative access to the machine. All you're going to do is to do a port scan from the outside. Are we doing okay so far? Differentiating, scanning, or having administrative right on the machine so you can actually do stuff on the machine versus from the outside where you may not have access to the machine itself. So one command that is really useful for accessing the machine from the inside is called, nope, this is from the outside, sorry. I take it back. This is from the outside, it's Nmap. Now Nmap, if you look it up, there's tons of material related to Nmap because this is the port scanner, okay, in industry. So white hats, people who work in the computer security field would know about it. They use it, very often. Black hats also use it very often because it's just an awesome tool for port scanning. Okay, can someone describe what is port scanning? What does it do? Go ahead.
Scanning the computer for open ports and services.
Exactly. Yep. And what exactly is a port? Can you kind of?
It's I mean I know what it is in my head. I have trouble explaining it. It's almost just like an area where a program talks to connect to services. Processes connect to services.
Now, the concept of the term port has to do with two specific protocols. Do you guys still remember from last Thursday which two protocols has the concept of ports?
TCP and UDP.
Yep, exactly. TCP and UDP. These two protocols are fairly useless all by themselves. This is not to say they are useless completely, but they're useless by themselves. ICMP is not useless by itself. It has its own purposes. Okay, but TCP is like, oh, this is a pipe. Do whatever you want with this pipe. Okay, UDP is kind of like, oh, here's an envelope. Okay, you can send a datagram to somewhere else. What's in the datagram? What is the purpose of this datagram? I don't care. My job is to make sure it gets to the destination. That's all. Okay. So UDP and TCP do not have any particular application or a particular purpose to itself, to the end user, and that's why we have ports. Okay. There are 65,536 ports to each protocol. Okay, each port, which is a number, identifies a particular kind of service. Now, the mapping between service and the port number is not hard-coded, it's not hardwired, especially with the higher numbers, like port 8080 is not always mapped to a certain type of service, but there are conventions. Okay, so with the lower numbers, I think they're fixed, they should be fixed. So port 22 is SSH, port 23 is FTP, port 25 is Telnet, and so on. But with the higher numbers, like 8,000, 8080, that kind of number, they are not really assigned. Okay, so there's a disconnect between the port number and what kind of surface we are actually dealing with. Okay. So Nmap is really useful for scanning from the outside, and there are several uses of Nmap. Now, before we move in and actually talk about the command itself, which seems really simple, right? If you just read my notes here, you go like, oh, Nmap is really easy to use. You just have to specify Nmap dash lowercase s uppercase O and then the IP address, and we're done. Well, that's one of the many uses of Nmap. Okay, so I'm not going to go through all of the different ways to use Nmap in this class because you will be able to find resources out of this class to get it done. The first one, which is the most accessible help, is just the man pages. So if you say man nmap or any command in Linux or Unix, you will find the man page. The man page is called a manual page, but in this case, it's not really just the manual page. If you look at the top of that page here, this is the reference guide of Nmap. In other words, it is long, it is comprehensive, and there's a lot of stuff to it. Okay. So for those of you who really want to kind of get into Nmap and port scanning, go ahead and read as much as you can and as much as you can absorb, okay? Because there are a lot of options. This is also, a demonstration of the concept of open source, the power of open source. Nmap is an open source, program, And as a result, when people think of different ways of doing things or new types of scans, they just add to the tool itself. It's not one person writing the entire program. It's not even one company writing this program. It is basically everyone who is interested. Okay, so everybody can contribute to this project because it is an open source project. Are there any questions about the nature of Nmap? Okay. If there are no questions, I'll just kind of briefly describe this command here. So this command, you have to run it as the root user, and using dash as this is an uppercase O. Okay, so what it's going to do is it will check out what type of subprotocols of IP is supported or the system is surfacing it. Okay, so we are not even talking about TCP or UDP, which themselves are subprotocols of IP. We are talking about ICMP and the other subprotocols of IP. So it will first identify what subprotocols of IP are supported by a particular IP address or something that it can get a response out of the system. Okay. If you have your virtual machine up and running, you can actually do it to the virtual machine itself. Okay, so you can basically SU to switch to super user, type beer for the password, and then just run nmap -so uppercase O, and then without scanning other machines, we can just scan ourselves. Okay, this is the local host IP address. Yep, go ahead.
I was going to say, isn't that the loopback address?
Yes. Yep. So we are only scanning one particular interface of the machine. This won't trigger anything from the outside because we are not even talking through the network cards. But yet it can still give you some information. Just give it some time to run, and it will come back with an answer. Okay, it will come back and say, oh, okay, these things are open, right there. Okay, so it's telling you, protocol 1 or subprotocol 1 of IP is open. Subprotocol 2 is open. What is ICMP? What is IGMP? Okay, now this is not a networking class, so I'm not going to go into these protocols and tell you what it's supposed to do. You can look it up on the internet pretty easily. Okay, and then we can see that TCP it responds to TCP, it responds to UDP, and it also has a 136. It is filtered, and 255 is unknown, but it is responding to. So this is seen from the local perspective. Okay, I'm scanning from inside the machine. But if you change the IP address to an external address, you report scanning an external computer. Now, doing that in a corporation can get you into deep trouble. Okay, because whoever is running the networking infrastructure can put monitoring equipment or appliances everywhere, so they can identify a port scan. They will know the destination, what is being scanned, and who is scanning it. And they will come to your cubicle in no time, and they will take you to a conference room and ask you, okay, what are you doing? And there might be security guards outside the door as well. You had that happen to you?
No, I was laughing. It's so true.
Well, it depends on what kind of company you're working for. If you're working for the national labs, oh yeah, there'll be armed guards, outside of the conference room because they don't know the nature of the scan, right? So they don't know how hostile the scan is. And I'm pretty sure with Visa, they treat this kind of stuff very seriously as well. And just because the PC itself is locked down doesn't mean this cannot be done, because you can just unplug the company PC, plug in your own laptop computer, and do Nmap. And they will.
There's a person right next to me that actually went to a website and got a virus.
Oh.
It was detected within 5 seconds. The phone rang, and the first thing they yelled at was, unplug your network, unplug your computer from the network.
Right now.
Right now.
Yep.
And turn off your computer.
Mm-hmm.
And they came and got the computer and took it and did the forensics on it.
Yep, that is not a bad idea because because viruses can spread really quickly, especially when you have a really homogeneous setup like in Visa or any type of corporation. When I said homogeneous, what do you mean by what do you think I mean by homogeneous? All computers run exactly the same software with the same patch level. Okay, so if one machine can be infected by a particular worm or virus, every other computer are susceptible as well. And that's why it's a bad thing. Now on the other hand, if you have a really not homogeneous type of setup, people running different versions of Windows, some people use Mac OS 10 and so on and so forth, then the same virus may not be very successful in the network because it can infiltrate one computer because it is old, it has not been patched, but all of the other computers may not be running the same version of Windows, may not be running Windows at all, okay, may have different patch levels and so on. So that makes it actually a little bit less susceptible to having the entire company shut down by a single virus. All right. So the rest of this, you can kind of read about it. How do you scan only IP addresses, only TCP and only IDP, and how do you read the result? What does it mean when something is closed, something is filtered, something is open, and something is open bar filtered? Okay, so they all have specific meanings, and it's up to you to kind of read it. If you have questions after you read it, do not hesitate to ask those questions in the forums. Okay, that's what the forums are for. It kind of replaces some of the class meeting time, so that we can actually answer questions and ask questions after the class has ended. Okay, now if you want to specifically scan for UDP and TCP ports, this is the way to do it. Okay. It is the same command, okay? Nmap is the name of the command, but this time instead of using uppercase O, you use uppercase S. You have to specify -P to specify the following is the range of port numbers to scan for, okay? So we typically scan from port 1 to 65,535, and then you specify the IP address. Now by changing the range of the numbers, you can speed up the scan. Because if you say, I'm not interested in this range of port numbers, you can just say, oh, okay, we'll just go ahead and scan from 1 to 4,095. Okay, so that will speed up the scan because it's not going to scan the other 60-something thousand ports. Are we doing okay so far with this? Okay. The way these commands are specified is not stealthy. Okay, in other words, it will hammer the other computer like with lots and lots of packets. Okay, which also means if there's a intrusion detection system running on the other side, it will probably pop up and say, I'm getting port scanned. The other thing you can do with Nmap is to specify the stealthiness. Basically you can do the scans slower, so it won't trigger the IDS as easily. Okay. But those are the stuff you can read about on your own. Okay. So what do we do with the scan result? Well, the next slide will tell you what to do with it. Okay. Because the scan result will tell you what ports are open. So the next question is, okay, now that we know a particular port is open, what do we do with it? So if you can get administrative access to the machine, then you can run netstat. Okay, so netstat can only be run on the machine that you're accessing, and you can run it as a regular user, but it doesn't tell you as much useful information as when you run it as system administrator. Okay, so I'm just going to do it here to show you, what it looks like. The output of netstat -TUNLP. The order is not important, and I'm going to pipe it through less. Okay, the vertical bar symbol. Let me just put this up a little bit more. The vertical bar symbol is called the pipe symbol. What it does is it will take the output of the first command and give it as the input of the second command. This can potentially give you multiple lines of output and will scroll up. So instead of having the screen to scroll up and I cannot read anything, I'm going to pipe it to less. Less is a type of program called a pager. In other words, it formats a text file or something that is in text into pages. You can page up, page down, you can search, you can do all kinds of, you cannot edit, okay? You cannot change it, but you can do all kinds of navigation using less. And this is the output. The output does not actually fit in the screen size that I have here, so I'm going to resize it a little bit so we can see better. Okay, so this is the output, and the screen is cutting off the left side. Let me just do the auto setup and see if, oh, there we go, it fixes the problem. So on the left column, we can see, it's TCP or UDP, okay, UDP 6 and TCP 6, okay, version 4 versus version 6. The local address is where it is listening for that kind of traffic for that port. Okay, now that is important. If you see there's none here. Okay, if you see 127.0.0.1, okay, as the local address, then you have no concern. Okay, because it means that only a local program can open a connection to that port, which means it's not coming from the outside. Okay. When you see 0, yep.
Say it again, 127.
127.0.0.1 is localhost. So that means it will only respond to something that is local to the machine that you're accessing. Okay. When you see 0, 0, 0, 0, then you have to be extra careful because this means all interfaces. Every single network interface, this particular port will respond to any request coming in from any interfaces. What is an interface? Any NIC. Okay, if you have 2 network cards installed, it will include both of those on top of localhost. Okay, so 0, 0, 0, 0 is the one thing that you really have to watch out for. Anything that has an IP address, you should also look out for, like this one here. This is basically saying it is particularly listening to the interface that has an IP address of 165.196.100.127, which is a proper IP address, okay? And that corresponds to ETH0 on this computer, which is the first Ethernet port of this computer. So it is still listening to outside connections. So that's also important, and in fact, all of these, they're all listening to the outside world. So all of these are important. We'll take a look at the foreign address here. That's not of any concern when we are checking for ports that are being listened to, okay? Because these are ports that are basically that can be found by the outside world, and somebody can initiate a connection to these ports, and that's what we are concerned about. Okay. If you do not specify the L in the command, it will actually give you not only the ports that are being listened to, but also ports that are connecting to the outside. It is useful on its own. Okay, if you suspect a computer has been hacked already, that will give you some extra information that is useful. But this is good for assessing whether a computer is secure or not. Is it listening to something that it should not be listening to? Okay, but the more important part is this part here. The right column, okay, has basically two things, but you can get to one, and then the other one is easy to get to. The first part, which is the more important part, is PID. PID stands for process ID. Can someone remind me what is a process? We talked about this last time already. It's a program in execution, an instance of a program. Okay, so all of those are proper terms to describe what a process is. So a process ID is corresponding to a program in execution. Okay, it uniquely identifies a program in execution. So in this case, we know that process 1554 is responding to port 445 of every single interface of the system. So now the next question is, what is this process? What is the program corresponding to this process? It's SMBD. SMBD is basically a Samba server. Okay, it responds to Windows share type of requests. Okay.
What? I'm sorry.
Windows share.
Windows share.
Yeah. So in a network of Windows machines, the protocol that they use for sharing files and drives is called SMB. Okay. So SMBD, I keep flipping the B and the D, is a daemon or a server program that is responding to it. Okay. Now, once you know this type of information, you can dig one step deeper. You can use PS, okay, which displays information about processes. So that will give you some extra information. So first of all, we have to remember the number 1554. Okay, so I'm going to run the second command. called PS, PSAF, and we'll do a pipe also, okay? Okay, this is a pretty, it gives you a lot of information. In fact, it will list all the processes that are currently active and running at this time, okay? So you can see, on one side, you have UID, okay, user ID. That is extremely useful, okay, for assessing, security risks. It's very useful. This column is PID, which is basically the number. We can search for the number later on. This is how much time it has been running. Excuse me. This is how much time it's been running. This is the start time. When did we start that process? And this is the command that was used to start that process. Okay. These ones are not. We're not too concerned about. We want to look for 1554. This is how you search inside the program less. Okay. So inside less, which is called a pager. I talked about this a little bit earlier. You can type slash, not backslash. Okay, this is forward slash, and then whatever you're searching for. Okay, if it is in the text, it will find it and go to that page. It's a very handy feature. So I press the enter key, and sure enough, we can find 1554. Let me just highlight which line we are talking about here. Okay, this is the line that we are talking about. Okay. So this was started at 50 seconds past quote-unquote midnight. And what is the UID of this process? It's the left column, root. Okay, so this is something that you really should look into, because this particular program is running with root privileges. What is so special about root? It is the system administrator in Linux. Okay, so any process running with the UID of root, which by the way is numerically speaking is 0, has access to everything in your system. Not just read access, it's read-write access to every single file and every single directory. So this is what will flag you and go like, oh, I better be paying attention to this particular service, because if something goes wrong, this can go really wrong. Okay, let me give you another example, go through another process. Okay, so I'll go through the same thing here, and this time I'll pick, let's say pick Apache, okay? So Apache 2, which I already know is a web server, okay, but in case you don't know, that's okay. Because what you can do is to look at the port number that it's listening to. It's listening to port 80, okay, and port 80 corresponds to HTTP. Okay, so we kind of know what the program is supposed to do. This is port 80, and most web server will listen to the outside world because that's the whole purpose of a web server. Okay, but the big question is, what about security risk related to Apache 2? Okay, is it posing a lot of security risk or not a whole lot? So we'll run PS again, and this time we'll look for 1422, which is the process ID of Apache 2. So now you can see it. Okay, the first one is 1442. It is started by root, but then you can also see the other ones. These are child processes. They are basically the ones that are actually providing service, and these are running as www-data, which is a user account with less privileges. Okay, but it was started by root. So these are the useful commands that you can use to kind of look into a system and find out, okay, what type of security risk are we exposing the system to. The rest of this is kind of repeating what I just said. Okay, if you look through all of this stuff here, I changed the command a little bit here so that it's not as overwhelming. So instead of looking at all the process, it is focusing on one single process ID. Instead of looking at everything related to that process, I'm only looking at UID and GID of the process. So it makes the output cleaner, but it is for the same purpose. How many people use a Dropbox or some sort of cloud service, cloud storage service? Okay, so if you use Dropbox, most likely or more likely than not, you have a local client installed on the computer. Okay, because the whole idea is you don't have to go to the website and manually drag the files around, right? Because one feature of Dropbox is it can synchronize. If you designate a folder on your computer as your quote unquote Dropbox place, then across all the computers that you own, they can synchronize the content. Okay, and it's all done in the background too. Okay, so that means Dropbox quote unquote client is really not a client. It is actually it might be listening to the outside connection. In fact, it does. Okay, because I had Dropbox installed on my computer, and I did exactly this exercise, and I go like, hey, what is this program? Why is it listening to a particular port number? Well, that's because when let's say you have two computers. Okay, I'll give you an example why it needs to have why it needs to listen to a port. All right, so we have computer A and we have computer B. Okay, one is a work computer and the other one is a home computer. Okay, so you want to use Dropbox to synchronize your files across these two computers. Okay. So you might have pictures, screenshots, or whatever that you want to synchronize between the two computers. So there'll be a file system here and a file system here. So the idea of Dropbox is a cloud service, which means it's on the internet. If you add any file to this particular folder, computer A will contact the Dropbox cloud service and say, hey, we are adding one file to this particular folder. Okay, that's fine. And that thing will be uploaded onto Dropbox so that if something happens to this computer A, the file can still be found on the cloud computer. But the cloud computer will do something extra. Okay, what it's going to do is if it is enabled, and I will let you know, how it is not easy to enable. But if it is enabled, this will actually talk to this computer, talk to computer B, and say, hey, there's a new file now. And it will try to bring the new file into this folder. So in order for the cloud computer to actively let computer B know about this new file, it needs to have a port to listen to. Computer B is listening to a particular port so that the cloud computer can connect to computer B and actively transfer the file onto computer B. Is that okay so far? Well, is it something that you want on your computer? Now, maybe it's worth the effort, maybe it's not. But I can tell you this scheme actually does not work most of the time. Because computer B, more likely than not, is sitting behind a firewall, your residential gateway. So that means the cloud computer can only get the IP address of your residential gateway. And it will try to make the connection to the residential gateway. But the residential gateway being a firewall, by default, will deny all incoming requests. So the request is already blocked here. So your computer can listen to that port all day long, but don't expect anything. Because the firewall would block everything coming in. But doesn't that mean, well, that means it's not a major security risk, we'll just leave it here. Well, that's not the case. Because you might have a computer C in the same local area network, okay?
Or on your mobile phone, right?
Or on your phone, right? But any device on the same local area network, okay? So if computer C gets hacked, okay? So computer C is already hacked. Computer C can now access all the ports of every single computer on the same subnet. Now, if Dropbox so happens to have a vulnerability, then computer C can be used to hack computer B, even though the port that it's listening to was never got, you never used it, you never used that port the way it's intended, okay? But a hacker can go through that to gain access to computer B. So if you don't use it, it is not doing anything useful, might as well close it, okay? You can uninstall Dropbox, okay, which may not be something that you want to do. Maybe you still want Dropbox to be running occasionally, okay? So you may not want to uninstall Dropbox. Dropbox may not even have an option to say, oh, okay, you don't want me to listen to that port? Fine, I'm not going to configure myself to listen to that port. But there are ways to stop, to close a port, okay? So the next slide, let's see here. There's one that talks about that. This one, this is a repeat of what I just said, okay? If you have any type of port forwarding, those are the first thing you need to look for first, okay? So go through your residential gateway configuration and just take a look at what ports are being forwarded and which machine it is forwarding to, okay? Because one particular port from WAN, from the wide area network, can only be forwarded to one internal IP, okay? So you want to look at the list, the laundry list of all the ports that are being forwarded, and first ask the question, do I need all of these port forwarding? If you look at those lists and you go like, I have no idea what this port number is corresponding to, well, you might want to look it up, okay? Why is it being forwarded? What does it do, okay? What happens if I close it? What if I turn off that particular port forwarding rule from your router? Would it be anything bad, okay? So you want to assess all of those things, because any port forwarding is basically saying if your residential gateway is getting a connection request, it will forward that request to whatever machine it is forwarding to. In other words, it is exposing the machine from your local area network to the internet. Now, I know it's only one port, okay? But that one port may hook up to something that can have a lot of risk associated with it, and as a result, you can still get something into your local area network. Yep.
Would you recommend running it from behind the firewall, just installing the drive, and then running Nmap on your system, bouncing it off the router and see what's open, right? And then go into router configuration and see if any ports are forwarded.
You can check whether a port is forwarded only by looking at, well, okay, there are two ways to do it. You can do it from the outside, okay? So from school, okay, if you know the IP address of your home, your residential gateway, I'm not gonna do it here, but potentially I can see someone doing it, okay, from the outside, okay? But the best way to do it is to look at the configuration of your router, just so that you can see what ports are getting forwarded. You can check the rules of port forwarding. Yep. The problem of scanning from here to your home computer is the monitoring equipment or appliances of the district may identify this as hostile.
No, I was thinking of installing, running the external plug-in into my home computer.
Oh, okay, I see.
Just booting directly and then just bouncing from behind and see what I can see.
Okay.
But
You can do that.
But it's probably good. I just wondered if there was something that the router configuration menu did not tell me that I could.
Okay, I see your point. So what you want to do, what you're suggesting is, okay, let's say this is your residential gateway, okay? So all residential gateway has a WAN side and a LAN side. So you're saying that you're going to hook up a particular computer, your own PC here, to be quote unquote on the WAN side, and then you have the usual LAN side here. So this way you can run the port scan directly from the PC to the WAN side of your residential gateway. Is that what you meant?
Yeah.
Okay.
I just didn't want Comcast calling me and asking me why I was trying to hack their network.
I don't think Comcast knows. I don't think they care either.
Okay.
I think as long as they keep collecting fees from you guys, from all the subscribers, they go like, it's all good. Because monitoring this kind of stuff requires quite a bit of processing. Because just think about the volume of all the packets flying around with Comcast or Shore West. Okay, that's a lot, right? And then for each packet, you have to run it against and match up several rules, not several hundreds, thousands, okay, tens of thousands of rules to see if it is matching the fingerprint of something that can potentially be hostile. And something cannot be one single packet either. You have to look at the pattern. So you have to keep track of a history of all the recent packets. That takes a lot of computation power and resources. And Comcast, if they don't have to spend this kind of resources to do it, they won't do it. The one thing I can guarantee you they will do is they will log all the traffic because that is required by law. So after the fact, they can submit that to whatever agency is doing the investigation. But while it is happening, I don't think Comcast has any appliances to detect problems as they happen. The only appliance they will run is to check your bandwidth. How much gigabytes have you uploaded or downloaded? That they would do. So they can charge you extra.
Yeah.
Or throttle your service.
And throttle your service, exactly. Yep. All right. So the next thing is to ask do I need this port with peers of the same local area network? With Windows file sharing, if you want to share files across all the computers, you need to open those ports, at least to the peers of the computer. Okay? Are there any questions at this point? So this is all kind of theoretical stuff. I showed you a few commands that you can run. The next slide talks about how do we stop it. Okay, if I want to stop it, and say I don't want that port to be open anymore, what do we do about it? Well, this is how we do it. Okay, so I use Dropbox as an example. Okay, Dropbox has an exposed port that it listens to, which is 17500. I think that is the case for all installations of Dropbox. Okay, so the command to do this is to use IP tables. IP tables is a complicated command to use to begin with. Okay, so I'm not going to focus too much on the command itself. I will only show you instances of how to use it for particular purposes. So in this case, I can use IP tables -a input -p, which port TCP, which protocol is TCP. Destination port is 17500, and I want to drop the connections. I want anything that's coming in, this rule will say drop it, so it won't connect. This is not uninstalling Dropbox. It is simply plugging the port that it listens to. Okay, so that's kind of nice in a way because you can. I think Dropbox has a fallback mechanism. In other words, if the cloud computer cannot actively contact computer B can still run and actively check back with the cloud computer and go like, oh, do I have anything new? Do I need any update? Are there any new files? And so on. So it will still get updated. It's just that it's not going to use port 17500 anymore. Okay. Any questions about this command? The command itself is explained here. Okay, so I try to explain to my best ability how to specify a rule with IP tables. IP tables is not persistent. Okay, by itself it is not persistent. What that means is you can run that command. Okay, and as long as you keep the computer running, that rule will apply. It will drop all incoming connections to port 17500. But the moment you reset or restart your computer, it will forget because IP tables is not persistent. So what you need to do is to install a different package called IP tables persistent. Okay, this is the name of the package, and you have to run it as root because you are installing a new package after all. But once you have this, you can then run this command only once. Okay, you only have to do it once. What it does is, okay, let me just show you the individual parts of this command. The first part of the command is IP tables -save. It is the actual command. The output of the first part of the command is the text output of all the rules that IP tables has at this point. Okay? The greater than symbol is called a redirection operator. In other words, it will take all the output of the first command and send it to the file that you specify next to it. So in other words, it will save the content, the output of the first command, into this file. This file is /etc/iptables/rules.v4. And next time you start up your computer, your startup script will actually go check this file. And if that file is present, then it will bring in all those rules in again. In other words, you are making those rules persistent. They're non-volatile. Are there any questions about this slide? The concepts, okay? The commands, you can look it up, but the concepts are more important. Okay. If there are no questions, let me see if my other script, or the command that I was running a little bit earlier, oh, it has concluded. Excellent. Okay, this is what I started a little bit earlier because this is your homework, by the way. Okay, so your homework is to do something that I just did, okay? But you're not going to do it to the computer itself, to the Linux environment itself. You're going to do it to a computer that I have already completely set up. So I'll give you 2 virtual machines. Okay, let me show you what I mean by 2 virtual machines. And I'll also show you the instructions of what you're supposed to do. It is virtual machine and network. It used to be somewhere higher up in the other topic. I just moved it here, okay? These are the instructions to get this working. So I will do it once. Don't do it now because you won't have enough time right now to do it. So just kind of focus on what I do and ask questions, okay? Especially questions of why, okay, what, and how, okay? But the why part is very, very important. In classes like this, I think there's a tendency to focus more on the how. Okay, give me the commands. How do you spell it? What punctuations? Is that an uppercase or lowercase c? Okay, so we kind of focus on the little details, but we're forgetting about the big picture. Why are we doing this? Okay, so the why is also important in this case. Okay, first thing first. This is a link to a folder that contains, right now it only contains 1 single archive file. I will go there, but I'm not going to download anything because I have already pre-downloaded that file. It took a while. So let's see. It wants to sign in. Okay. So in order to do this, you have to go to apps.losrios.edu, sign in first. As much as I like my computers and whatnot to be secure, having to reset my password every 90 days still bugs me.
Do you have to go to Google Drive?
Hmm?
You have to go to Google Drive?
It will bring you to Google Drive, but you need to authenticate first. So now it will connect to the actual folder. So inside the folder is 1 single file. It's ciss342.r.bz2. You can, if your home connection is slow, you want to do it here. Okay. So if you have your external hard drive with you, go ahead and start the process. Okay, because it will take a while. It's 3-point-something gigabytes. Okay. So to download it, I'm just going to show you. If you click it, it will just have a. It doesn't know how to preview it, which is okay because it's way too big. You just click download, and depending on your browser, you might need to specify where you want it to download to. Otherwise, it will automatically download to the downloads folder, which is okay. You can just move it around after it is downloaded. But it will take a while. Just keep that in mind. All right. So the next thing is, okay, now assuming I have that file downloaded, and I do have it here. Let me just show you that. Okay, so I have that file already downloaded. It's actually only 3-point-something gigabytes, but this is the base 10 version of the Giga, and that's why it shows as the 4 gigabytes. The next thing you have to do is to decompress it. That will take a long time as well. Okay, let me check how long it took me to do it. Using a USB 2.0 connection, an external hard drive. Okay, are you guys okay back there?
Yes, I'm setting up my drive.
Okay, well let's kind of focus on this stuff first, because we can kind of do that later. Okay. All right. So you can see how long it took to get this done. It took this computer 13 minutes and 26 seconds to decompress everything, which is not terrible, but it is bad. Okay, it's kind of long. If I did not use an external hard drive and I get a flash drive instead, one of those solid state thumb drives, it can easily quadruple this time. It will take it can take an hour to get the same thing done. Okay, so that's why I want you guys to use an external hard drive, because even with an external hard drive, which is fast, it will take this long. Okay, so when you decompress it, you run this command, tar xjvf, and then the file name, like so. and then it will create a folder. It will create a folder called ciss342, and in that folder it will have 2 scripts, 2 virtual disks, and one text file. Okay, I'll show you exactly what it is because I have this done already. I just started this right before the class. Okay, so this is the content of that file, and we have info.txt, which is just the passwords of one particular virtual machine. So when you look at info.txt, it says here for the DHCP server, which is a kind of a smaller virtual machine, the username is user, the password of user is live, and then the root password is beer, okay, which is consistent with your live environment. With the other one, which is the machine that you are going to evaluate, the end user's name is casual, all lowercase. The end user password is fluffy, and the root password of that machine is not so secure, with uppercase S in both cases, in both words. Okay. All right. So this is nothing more than just a text file. I include it in the archive just so that people won't ask me again. So what is the password of this machine? Well, check the text file. Okay. I cannot run these scripts for now because they rely on VDE. Okay, we talked about VDE briefly last week. Okay, virtual distributed Ethernet. Okay, so what we'll do is we have to run a few commands first before we can get that to work. So let me close this first. Are there any questions at this point? Okay, if there are no questions at this point, we're going to set up VDE. Now this is a multi-step process. The first time you do it, it can be a little bit confusing. Okay, so don't hesitate to stop me and go like, hold on, what did you do? Why are we doing this? Okay, so the first thing we want to do is to run this command as root. Okay, so some commands you have to run as root, some commands you want to run as user. So you have to kind of keep track of that. Okay, which part is running as root and which part you have to run as user. So here's my command line, and I'm going to scroll this description here so I can see both the description and my command line. Go. Okay, this is the best I can do. So I'm going to change to be. You guys cannot see it. Okay, fine. There you go. So I just changed to use root user first. Okay, so I can run the tunctl command, tunnel control. Okay, so tunctl-u user. Just checking back, right? There you go. Okay, so this is an important command because what it does is it sets up a virtual adapter, a virtual NIC, a virtual network interface card inside the host environment. We don't have any virtual machines running just yet. Okay, we do not even have VDE running yet. Okay, all this is going to set up is what we call a virtual network adapter or virtual NIC. Okay. It's a virtual device. It doesn't actually correspond to any hardware, but it has all the same properties as a network card. Okay? So later on we'll be using it, but right now we're just creating it. Did I misspell it? It's not included. Okay. If it's not here, you have to install it. Okay, it's UML utility, so I have to install that package. So install UML-utilities.
Is this in the instructions what you're typing right now?
Hmm?
Is this in the instructions?
It's not in the instructions because I forgot to install UML utilities in the live environment. So you will have to install it first before you run it. And you have to do it every single time because it is not, that part is not persistent. I will add it to the instructions now. Okay. So you have to install this package to get that command. So press the enter key. All right, so it is now installed, and we can run the tunctl command now, and it will just create a new network interface. The network interface that has just created is called tab 0, okay? And it's owned by UID 1000, which is the end user account. Okay. Are we doing okay so far at this point? Yep.
So we have to,
You have to run aptitude install.
we have to first download the tar file and then untar it and then go to that directory and then install it.
Correct.
Internal
Now
control.
the tar file, you only have to download it once
Okay.
and expand it only once, okay?
Okay.
Because that's a lengthy process.
Okay.
Aptitude install UML-utilities.
That first.
You will have to do it every single time you boot with the live environment because that part is not persistent. There's a way to make it persistent, but I found that it creates more problem than it solves if I make that part persistent.
Okay.
So you will have to run the aptitude install command every single time because whatever is installed is not it doesn't stick. Okay. This you have to do it every single time as well because it's not persistent. So the new network interface, the virtual network interface, is not persistent. When you restart your computer, it will be lost. Okay. All right. The next command that we run is, well, this is optional. Okay. Ifconfig is really just looking at all the interfaces that are up and running, and tab 0 is not active at this point. You won't be able to see it. But it is still a good idea to run this command to show you what we should be seeing normally. You can definitely remember this number, 127.0.0.1. That's our local host. It's called a loopback. And then we also have Ethernet connection here. This is my actual physical network card. It has an IP address of 165.196.166. Okay. And it shows you all kinds of information useful or not related to that network card. It says I have received 117 megabytes up to this point, and I have only transmitted 3.5 megabytes at this point. Okay, so it may be useful, it may not be useful. Okay, so the next one is VDE switch dash daemon dash sock blah 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 blah. Okay, so this you have to run as end user. Okay, so what we need to do with the command line is you can either open a new tab as a regular user, or you can type exit to get out of the root shell. You can do either one. Okay, I don't really care which way you do it. Just one way or another. Okay, I just use exit. I use the same terminal for both. Okay. So this command is fairly long. You can copy and paste if you're using PuTTY, but if you're using the console of the virtual machine, then you cannot copy and paste. Okay, but since you'll be using the same environment that I'm running, you can actually do it. So you can just do it the easy way. Copy from here, switch to the terminal, and then paste like so. Okay, but yep, go ahead.
So we're leaving root and going back to regular user.
Correct.
Just because we can still access, we still can't turn on the switch as a user.
That is correct.
Just because we can at that point.
Correct.
Okay.
Yep. So the switch, the virtual switch, is actually running with the same privilege level as a regular user. Okay. So because if we can do something as a regular user, we want to do it as a regular user. We don't want to run things as root unnecessarily. Okay. So that's exactly why I'm doing it this way. The command is VDE _ switch. Okay. The first what we call switch or option that we pass to this command is -daemon. In other words, without -daemon, this program will run, but it won't give the command prompt back to me. It won't give the prompt back to me because the program is running. So by using -daemon, it will run quote unquote in the background because that's all I need. I'm not interacting with this program by hand. It is pretending to be a network switch. /sock/temp/my switch is just one way to specify where the socket is supposed to be at. If you don't understand this part, it's okay. It's not a big deal. The last part is kind of important. #tab0. Remember what tab 0 was?
That's the Ethernet.
That's the virtual Ethernet thing, right? Okay. So this is basically saying, okay, here, power up this virtual switch. And by the way, hook up a wire from the virtual network card that I created earlier to one of the ports of this switch. Okay? So it's equivalent to those physical activities with actual hardware. Okay? So press the enter key, nothing should happen. Okay? Or as if nothing has happened. Okay? If you run Ifconfig again, I'm not going to run it here because I'm not root. It will show you that tab 0 is still not, it doesn't have anything to display. It doesn't have an IP address, it's not active because I haven't told the computer to make use of that network card. Okay, I just have a network card, it's now connected using a Cat5 cable to the virtual switch, but I haven't said anything about how to configure it. Okay, moving on to the next command. The next command is slurp, okay, slurp VDE, which is a kind of funny command. Okay, so before we actually paste this command, I will explain what it does. The switch is nothing more than a switch. Okay, so let's see what we have here at this point. Okay. This part you might want to copy on a piece of paper because it's not in my notes. All right, so we have a live environment, okay, which is a particular system. We use TUNCTL, okay, tunnel control, to create a virtual network card. So we have a tab 0, TAP 0, which is a virtual network card. It doesn't actually correspond to anything physical. But this computer does have an Ethernet port, okay? So it's not called ETH0, but I'm just going to call it ETH0 at this point. This is my actual physical connection to the outside world. So now this computer has multiple network cards, which is not a problem, okay? It is not a problem to have multiple network cards, multiple NICs on the same computer. Not a problem. I created a virtual switch, okay? So this is a switch. And when I ran this command, I also make this connection here. So the virtual switch from the live environment is now connected to the virtual switch. But the switch doesn't go anywhere, does it? It's just a switch sitting here with one wire connected to this part here. Well, that's not very helpful, okay? Because eventually, I want other things to be connected to the switch, and I want to be able to go out to the internet through the switch, through the virtual switch. So that's what slurp is for, okay? So this command called slurp is for that purpose. It basically starts a residential gateway that connects the switch to the internet, okay? So what it does is it will basically create a residential gateway. Okay, I'm just going to call this a gateway. So it will start with a gateway. The gateway is automatically connected to the virtual switch. But the gateway is also going to be set up so that it will go through my actual internet connection to the outside world.
They're not going to share an IP though, right?
It's sharing the same IP. This is going to be a NAT-based router, network address translation. Yep. So let's go ahead and run the command. Here we go. Press the enter key. Nothing should seem to happen at all, because I also run this as a daemon. The -D means run this as a daemon in the background. Okay, because there's no need for me to interact with this through the command line interface. Now you actually can do it without the -D, and then you can actually specify all kinds of commands to do what is equivalent to unplugging and plugging in wires to an actual switch. But that's not what we're going to do, so we're not too concerned about running it in an interactive mode. All right, next. So now we can finally run the DHCP server, okay? So this command is going to start up a virtual machine. So this is the first time we actually start up a virtual machine. So the virtual machine is called DHCP server. So this is now a virtual machine. I'm going to use a dotted line to represent a virtual machine. DHCP-SVR, which is a server, okay? You can look into the bash, the shell file itself, the batch file itself, to find out how things are specified. It's a mess, okay? Trust me, it is a mess, but I can kind of go through, some of the explanation. But eventually what happens is it will create a connection from the DHCP server to the virtual switch. Okay? Now, what is the purpose of DHCP or a DHCP server?
Assign IP address.
Assign IP addresses. Okay, DHCP stands for Dynamic Host Configuration Protocol. Okay, and one of the primary purpose of that protocol is so that the server can answer requests from machines starting up and say, because the machine starting up here will go like, oh, I have a network port connected to the DHCP server, and it will just ask, what should I use as my IP address? Who's the gateway? Who's the DNS server, and so on, and the DHCP server will answer those questions. Are we doing okay so far? This is not a machine that you have any type of concern about. You can still log in. I give you the password to log into it, but there's nothing you have to do about it. Okay? You can just leave it running, by itself, and just make sure that you shut it down properly. That's all you need to do. Okay, well, we'll go ahead and do this. So we say /dhcpsvr.sh. Now, I didn't write it down here, but I should have. When you run this command, you might want to specify an ampersand at the end, because what it does is kind of like a dash D. If you don't specify an ampersand here, it will run, but it won't give the command prompt back to you. Well, you can always open up a new tab. You can always open up another command interface, command line interface, but this is more handy. Okay, just give it an ampersand, which is basically telling bash and say, run this command in the background. Okay, I have other things to do also. Okay. And I did not specify the instructions entirely correctly here, so let me just change the text here, so this way it is already updated. It is. So you have to specify a / to run it, and then an ampersand at the end. Oh, so I just updated my notes, to include that information. Alrighty. Okay, so the moment of truth is now, I press the enter key and it starts up a virtual machine. It looks just like, your virtual machine, or looks very similar, except this one is really quick to bring up, because the only thing it does is to serve as a DHCP server. It doesn't have anything else. So it should be relatively quick to start this up. Still wants to maximize the screen, but that's all it does, okay? It gives you the login prompt, and that's it, okay? All right, so with this one, you can just minimize it, okay? Because we won't be interacting with this particular virtual machine. Okay, going through the notes here, this is the next command. I know we have a lot of commands, but this is actually required. This command is running a DHCP client, okay? In other words, we are doing it so that we can get an IP address for the virtual network port that we just created a few steps earlier. Okay? Because without an IP address, it cannot talk to anyone. Okay? In order to call someone from a phone, your phone needs to have its own phone number. Okay? So we have to get the phone number for this particular interface first before we can use it to talk to anybody else. That command will do that. Okay, so when you run DHCP CD5, okay, which is the name of the command, -G tab 0, what it's doing is it will go through tab 0 and say, hey, I want to get an IP address for tab 0, which is the virtual network interface. And tab 0 is connected to the switch, and the switch connects to a virtual DHCP server. That's how this virtual network interface card is getting an IP address. Okay, so we are talking about virtual network card, virtual switch, virtual DHCP server. Yep, go ahead.
That command initiates the request to the server.
Correct.
And the response.
But only through tab 0 the interface of tap 0.
Right.
Which is the most important part, because you don't want to ask your Ethernet, your actual Ethernet connection to get a new DHCP leads.
Well, at this point, it only has one line into it anyways, right? So just
Correct, but you're running this from the host environment, and your host environment already has a physical connection through the back of the computer, or Wi-Fi in most cases. Okay. Now this command, unfortunately, is also not installed on your virtual, on your ISO file, so you will have to install it every single time as well. I apologize for these oversights, but I could not create another ISO file because Debian is in the process of changing stuff, so I could not get a consistent build. I've been trying like 3 times a day, since 2 weeks ago, and I still could not get a consistent build at this point. Okay, so this is what we have to do, at least for the time being, is to run as root. You have to run su here, and then we have to run this command first, which is aptitude install dhcp cd5. So we run aptitude install dhcp cd5. Press the enter key. It will install it, but it's complaining about one thing: fail to fetch. Yep, go ahead.
Why you have to type SU first?
Why do I have to type?
SU first.
To change to root. You can
Oh,
only
to change
install
it.
software when you're root. Okay, so it's not letting me do it. This can be a problem. Let me see if I can fix it. Oops. As soon as I can build a new ISO to include all of these packages, I will let you guys know. But I have been trying that for 2 weeks and several times a day, and I still could not, get a consistent build up to this point.
Has anybody downloaded that file off of Google Drive?
Yeah,
No.
Successfully? So mine failed.
Yeah, it goes for 2 minutes and then it fails.
Yeah.
Uh-oh.
Which one?
It goes for 2 minutes and then it drops.
It just drops out.
Yeah, it just says, I've tried to do it like 3 times and it failed.
maybe too many simultaneous attempts at the same
We have,
time.
I think that's probably the case.
and we have a success over here, so.
Yeah,
Okay.
I got mine, I'm already.
Okay, for those of you who could get it done, when we take a break, we can just kind of copy it out of each other's drive. So it will you will have to kind of take you'll have to turn off the machine to get it done. Okay, but we can do it during our break time. We can just copy the files. Yeah. All right, so I got it installed. We have to do an update first. I have to change this instruction because it has been more than a month since I made an ISO. Things are a little bit outdated, so I have to run a update first before I can install it. So I'm going to change the instruction here to reflect that. So we have to do an aptitude update and then the semicolon. So this is all one command. Let me use highlighting in the background to emphasize this is all one command. It's just wrapped around. There we go. All right. So we'll go ahead and run DHCP5 finally. Okay, so we'll run this command here. Copy and paste. Press the enter key, and this is what you should see as well when you run this command properly. And just from the output message, you can definitely tell that that particular virtual network card is now assigned an IP address of 10.02.102. Okay. Yours should be the same because we are all running an identical configuration of the DHCP server, so it should assign the same IP address. Okay. So now, if you want to update this picture, this guy now has an IP address of 10.02.102. This from an earlier, oops, not this one. Excuse me. I looked at the wrong interface. This one here. This is 10.0.2.102. This one here, from an early IP config is 165, 196, 166, I think. Close. I know the last one is 66. I just cannot remember whether this was 100 or not. I think it's 100 and something. Okay. So now this machine, this one single machine running the live environment, has 2 network cards, quote unquote network cards, and 2 different IP addresses. It's not a problem. Okay. A particular machine can have as many IP addresses as you want. Okay. Now that this step is done, we can finally run the last one, which is test.sh. Okay? To run this, you have to do a / in front of the test. But we want to run it as user, so I'm going to get out of root again to run it as user. So test.sh is the name of the script. And I'll put an ampersand here just so that I can run other commands after this. And this is the virtual machine. This is the virtual machine for the test platform. This is the one that we are evaluating. Okay.
At this point, do I have 2 versions?
Yes, we have.
Of QEMU running?
Yes, that is correct. But they are running different virtual machines. One is running the DHCP server, and the other one is running the quote unquote honeypot, the thing that we are evaluating and trying to secure.
And they're both linked to the VDE in the back.
That is correct. Very good. That is correct. So at this point, if you want to update the network picture, so what we have now is our test virtual machine is now also up and running, and it is also connected to the switch. Now this one, is a quote unquote typical client computer. So it's automatically running the DHCP client, and it has an IP address already. I'll go in and show you. Okay. So now let's be very careful, because when we look at this interface, it looks almost identical to the live environment itself. Okay. After I log in, you guys will go like, oh, this is the same thing, but it's not. This is actually a virtual machine. Okay. So I'm going to log in as casual. This is a casual user. Casual. And the password is fluffy, all lowercase, FLUFFY. Sign in. And after you sign in, you will see the same graphical user interface as the live environment itself. So definitely make a point to make sure you don't confuse yourself. Okay, which environment am I in? This is the virtual machine, not the live environment, which I call the host environment. So this is a guest environment, not the host. Okay, but I can run pretty much the same commands here, just a little bit slower. Okay, so I can su. Okay, remember what is the password of root of this platform that we are testing? Not so secure. Very good. Okay, not uppercase SO, secure also uppercase SECURE, and I now just sign in as root on the platform being tested.
That's a not with a T, right?
That's a not with a T, right?
It is.
It is.
Because on the file that you read, it didn't say that.
No?
It said no so secure.
Oh, it's not. It should be. That should be a T. I apologize for the typo. Maybe intentionally have a spelling mistake is a good idea for security, because. Okay, so now as root here, I'm going to run Ifconfig, because I can now show you the Ethernet connection from the virtual machine has an interface, has an IP address of 10, oops, not here, this one here, 10.0.2.101. Here you go. So they're in the same subnet. They can now talk to each other. That is the key. So now the host environment having an IP address of 2.102 and the platform being tested having an IP address that ends with 2.101, now they're on the same subnet. Now they can talk. Now I can start to run Nmap from the host environment to test the machine being tested. That is your homework assignment. Yep, go ahead.
Is the DHCP server, is that going to assign those That type of.
Yes.
So it's going to be the same for.
Yes,
Okay.
yes. Yes, the test platform runs DHCP client automatically.
Okay.
In other words, once it connects to the virtual switch, it would go like, hey, I don't have an IP address. Can somebody tell me what I'm supposed to be, or what is my IP address? The DHCP server will respond to that request and go like, oh, okay, I can assign you the next number, which is 10.02.101, okay? Now, when you run this, you might get these two numbers reversed, okay? The reason is DHCP server actually keeps track of MAC addresses and IP addresses that it has assigned previously. And because I have run this already and in a particular order, that's why I got these numbers. When you run it in a different order, you might get the virtual environment, you might get the live environment to get 101, and then the test machine to get 102. Okay, so use Ifconfig to figure out what is the IP address of a platform. Yep.
Well, maybe I answered it. So when we brought up the DHCP server,
Mm-hmm.
we ran that tap request.
When
That's
we
it issued the first number. Right?
okay, in the ordering of things, this is how we order things. The first one is to create tap 0. That's the first step. Second step is to create the virtual switch.
Wasn't it done at the same time? Did we?
Nope, not at the same time.
Okay.
The interface was created first using TUNCTL.
Right, I wasn't quite sure who was doing that.
Yeah, the first command is TUNCTL. It creates the virtual interface in the host environment. That's step 1.
But we did. Who's doing that?
As root
No, I'm
in the
saying
live
not what
environment.
permissions are used. I'm saying which program's issuing that.
Okay, let's flip to that note here. Now this has to be, I have to be careful because I have to see which environment I'm in. This one here.
Right.
This creates tap 0.
But who's doing it? Kimu, VDE, Dev?
No, on the command line of the live environment.
Yeah, that program, TUN.
Right, but he's assuming that those are already downloaded and installed and stuff. I'm saying I could run it through Debian, right?
Yes, you can.
Without those being installed.
You have to, well, in this case, because I did not install UML-utilities, you will have to install that first.
Okay, so this is assuming that they're already up and ready to go.
Right.
Okay.
So you have to run it as root. So basically, you have to do that part first.
I got that.
Yep. And then the second step, the second thing we did was to create the VDE switch. That's the second thing we do.
Right.
And then the third, well, the second, well, it's creating the switch, but we're also connecting the wire between those two. So you can kind of look at this wire as 2.1 because we are making that connection in step 2 also. Okay. Step 3 is to create the virtual machine that is running as our DHCP server. So this is actually step number 3. Okay. Step number 4 is I need to get an IP address for the virtual network card. So this is actually step number 4 is to get the IP address here.
So I think maybe like, the only thing I'm missing here is, so you run the VDE, he gets up, but still doesn't have any IP address and nothing assigned to it, right?
Correct.
It just kind of lingers in the
Actually,
background as a
okay.
daemon, right?
I forgot one thing. I forgot about the slurp, the gateway. The gateway is actually the 3rd step. This would be the 4th step. This is the 5th step. And this is the 6th. This is the last.
So who's running the gateway? Is that the VDE environment?
The gateway is started by the command called slurp VDE, and that is run in the live or the host environment. All of these commands, you have to run it from the host environment.
They're just daemons that run in the background off of Dev, right?
That is correct.
Okay.
We set up VDE switch is a daemon. Slurp VDE is a daemon.
And they just linger in the background, right?
Exactly.
And they still, but they're running, their processes are just hanging out back
Yep.
there. but they still don't have any IP addresses. It's not until we run the DHCP server.
Well,
that-
they don't have any IP addresses. The gateway had an issue, has its own IP address, but VDE as a switch itself has no IP addresses whatsoever. But it's a program running in the background, emulating the behavior of a network switch.
And the gateway's going to receive its IP from where?
It is hard coded.
Okay.
So the gateway has an IP address that is hard coded.
Okay.
But I made the configuration of the DHCP server consistent with that. So everything will still be okay. Now this is the check, okay? So let's go into the virtual machine being tested, okay? So that would be this virtual machine here, okay? It already has some application installed. It doesn't have a whole lot, but it does have a browser installed. This is inside the virtual machine, okay? So this is the moment of truth, because if this browser has the ability to go to, let's say, moodle.lostreals.edu, it has internet connection. It is going through the virtual gateway, which in return go through your actual internet connection in your host environment to go out to the internet. So let's go ahead and try this to be sure. I'm pretty sure that works because I've done this many times. So moodle.lostreals.edu, and this is confirmation right there. Okay, this message can only be displayed if I make a connection to the server. So yes, so the answer is now we have the whole thing up and running. This is your lab. I know it takes a while to bring it up, but it is very useful because now you have a virtual networking environment where it is completely disconnected from the outside world. If I did not do this step here, if I did not go to an external website, you could have disconnected your actual internet access and still be able to do the experiments that you have to run in this class.
So we don't need to be at home if we're running the lab. We don't need an internet connection.
Correct. Once you have everything set up.
Okay.
Unfortunately, you have to install those packages. There are ways to do that. You can actually download a whole bunch of DAP files and just keep it on your persistent drive. So this way you don't have to re-download those things, over and over again. So I can package those things up and give you one single command. So instead of having to install this and that and whatnot, I'll give you just a whole bunch of DAP files, give you one single command, and it will bring your system up to date. Until such time, I can update the ISO file itself. But I have no idea when I can actually do that because it depends on when Debian will have all the packages being consistent. Yep.
So we can have those packages without the updated ISO. Is that what you're saying?
You cannot update the ISO.
Okay.
The ISO is a read-only medium.
Okay.
But I can download all the DAP files, package everything into one big huge zip file. You can download that zip file into your persistent partition, unzip it, and then every time you run your experiment, you can just run one single command. It will just get all the things done.
Okay.
Yep. All right. So this is good. I'm just going to run one little thing just to verify. Okay. Your homework assignment is more involved. Okay. I'm just doing this as an illustration. Okay. So I'm going back to a command line of the host environment itself. Okay. And I'm going to run. Let's go switch to this Nmap 10.0.2.101. Okay. So now I'm running a port scan, not to the live environment or the host itself, but to the guest environment that I have just started to run, the virtual machine. Okay. So let's see. And I'm running Nmap without any options, so it will just give me some overall information. So it does tell me something, okay? It's telling me that FTP is open, okay? It's telling me RPC bind is open. It's telling me the IP address, the MAC address is 525400 and so on. So, it does work, okay? Your homework assignment is to use the other commands and give me a much more detailed report of what you think of the guest environment, okay? And I'll bring you to that homework page, and then we'll take a break. Okay?
would you
Yep.
prefer us to create, through Nmap, you could create like a page, right? Almost like an HTML document?
Yeah, it's
Maybe
going to be it's a journal. Okay,
Okay.
this type of homework is called a journal, and these are the questions. Okay, so you just have to read through this. Okay, and you can always refer back to the instructions earlier. It's not a closed book type of assessment. You can open up Google, you can open up the other pages, you can look up your man pages and whatnot. But the idea is I want to do an outside scan, okay? So don't log into the virtual machine and run as root over there, okay? I want to do an outside scan and find out what IP protocols are supported by the virtual machine. And I want, specifically for TCP, what ports are open, okay? And answer these questions. And then do the same thing with UDP ports, okay? So basically you'll be more or less repeating some of the commands that we ran through today, but you will also have to kind of do some research and go like, oh, what is the name of that protocol? What is it used for? Okay, so you have to kind of look that up yourself and just find some information. I specifically made the test machine to have some well-known protocols that have known problems. So when you read up the material on those protocols, you will go like, oh, that's not good. And then you can explain, oh, this is not good because blah, 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 blah. Is that okay? Are there any questions about the homework assignment? And that's a journal. So with a journal, it's I think it looks like an HTML document. I'm just going to use a incognito window so I can log in as a student and try this out myself. Has anyone tried it out? Started out on the journal? Okay, I will just go ahead and start it.
The output though,
Yeah.
would you just like, or are you gonna be grading the output or just our findings?
Your findings.
Okay.
You can, well, if you don't mind, because it's just copy and paste, just copy and paste the output
Okay.
of the commands. So this way you can refer back to the output and go like, oh, look at this. According to this, it is port, 23 is open and it's corresponding to FTP. I want to sign in as a student. And go to this class, because I just enrolled myself into this class. It won't let me do it because I have to go through the syllabus first. Okay, so I'm gonna do this real quick. For the second half of this class, I probably will stop the recording and I'll just be walking around to make sure that you guys are, get everything set up here, okay? Because if you can set it up, here, you can do the same thing when you're home, then you'll be able to do your homework, whenever you want to. Oops, missed one. That's a long syllabus. But that's what I was asked to do, okay? This was not my idea.
You feel the pain now.
I was asked to spell out everything.
So, build our pain.
It's like a book by itself. All right. Now that I'm done with this, I can actually do something. Instruction is not available. Did I get a less than perfect score? Oh, I did not turn it in. I did not submit. All right, fine. Okay. And so save, submit all, and finish. And that's what I forgot to do. I did not submit. All right. So now the other topics should be open. Yep, they are. Okay, so this is what you should see when you click on a journal homework. That's the description. Then you can say start or edit my journal entry. And that's just an HTML document.
So we can Google this out, right? Like looking for the answer? Or it just from the VDE?
You actually have to do it to figure out the answer. Yep. That's why we
Different
set
ways.
up these. That's why we have this, 6-step, setup, so that you can do the homework.
Yeah.
Yep.
I have a problem with mine.
Okay. So are there any? But let me just check first. Are there any questions about this part? And by the way, if you're new to the HTML editor, you can click on this button here, and it will show you the other things you can do in the HTML editor. For those of you who do not like to be confined to a small box when you're editing, you can click this button here to expand to full screen mode. Okay, so this will give you more space to do your editing. The typical tools are here. Okay, these are the boldface, italic, bullet points, numbered, list. You can insert a link if you want to. Okay, so this is for inserting a link. This is for inserting an image. You can increase indent of a paragraph, decrease indent, change the color of the font, change the color of the background. All the usual basic text editing features are here. Okay, so you guys can make it fancy if you want to. You can make it simplistic if you want to. But I just want the answers to be easy to find. Okay, so I don't have to read through 16 paragraphs of poetry to find out the answers. Like, oh, okay, so this protocol is not good. It should be blocked. So I don't need poetry. I just need something more to the point type of answers. All right.
Was there a specific reason why we were doing it in HTML? Is it just because there was an HTML editor there?
Just because this does give you the options. Because if you want to make a bulleted list, okay, the top level refers to the protocols, and then within the protocol you use sub bullet points to identify. Okay, this is according to my research, this is the function of that protocol. Should it be blocked? Yes, it should be because of blah blah blah. So you can answer the questions in bullet points. Yeah. So that makes it easy for me to read as well. But you can also, it's easy. It gives you a template of how to answer the questions. But it gives you all kinds of options because it's an HTML editor. If you don't like to use all those features, it's just text, right? But if you want to include, some, links and stuff like that, you can do that. Okay. Are there any questions regarding this homework assignment? No questions? Right. If there are no questions, we'll take a short break, maybe 10 minutes or so. My watch says it's 38 or 39 right now, so let's come back at 50, so we'll continue from here, okay? And during that time, I'll be uploading my recording onto YouTube.